We're going to get started here with section 3.5, the polarity of molecules. We kind of talked about this yesterday, but we'll go a little bit more into detail today. We'll kind of cover these two outcomes here today. Polar bonds are when one atom is more electronegative than another in a covalent bond. That means the electrons are not shared equally. So in this example on the bottom of the slide here, we have HF, hydrogen fluoride or hydrofluoric acid. We're not seeing an equal sharing. The electronegativity on hydrogen is 2.2. The electronegativity on fluorine is 4. So there's a big difference between their electronegativities. So the difference in electronegativities, like we did in yesterday's class, would be 4 minus 2.2 or 1.8. So this would be a polar bond. We did this, like I said, in yesterday's class. A polar molecule, so again, not talking about a polar bond, I'm talking about a molecule on in its entirety. A polar molecule is when electrons are not shared equally across an entire molecule. So your positive and negative charges are on the outside of the molecule. So water is a good example of something that is polar. We have our negative charge up here and our positive charges down here, and it creates a polar molecule. So there are a few rules you have to remember here. Molecules are polar if there are 3 or more elements in the molecule. So you can look at this example. Now, one thing I should stress is 3 or more different elements. 3 or more, different elements. So here I have hydrogen and carbon. That's only 2 elements. But here I have hydrogen, carbon, and chlorine. So this would be a polar molecule. So that's the first thing you need to remember. Molecules are polar if there are 3 or more elements. Molecules are polar if there are lone pairs on the central atom. So again, I have water on the left and I have methane on the right. Water here is polar because there are lone pairs on the central atom. And the third one, molecules are polar if there is no central atom and the elements are different. So let me go through that again. I'll go through the 3 rules. So rule number 1, molecules are polar if there are 3 or more different elements in the molecule. Rule number 2, molecules are polar if there are lone pairs on the central atom. Okay. Rule number 3, if there is no central atom and the elements are different, it would also be polar. All right, so I have a few examples here. Let me do 2 and maybe give you guys a minute to try 2. So the question says, are these molecules polar? Are the bonds polar? Well, let's see. So first things first, I'm going to draw the Lewis dot diagrams for these molecules. And hopefully my pen won't do that too much. So this is the Lewis dot diagram for, I say Lewis dot, I mean electron dot diagram for CO2. This is the electron dot diagram for HF. So first things first, I need to open up my periodic table and see, are the bonds polar? So just give me 1 second here. Just opening up my data book. So my bonds, I have carbon and oxygen, and I have hydrogen and fluorine. So what I'm going to do is make a mental note of these numbers here. So carbon and hydrogen and oxygen and fluorine. So hydrogen is 2.2, carbon is 2.6, oxygen 3.4, and fluorine 4.0. All right, let's write these numbers down. So 2.2, 4.0. Actually, let me pick a different color. Carbon was 2, oops. This pen. Okay, let me just double check again. Carbon is 2.6, oxygen was 3.4. Okay, so first things first, we're going to check to see if the bonds are polar. So 3.4 minus 2.6 equals 0.8. That's definitely a polar bond. Down here, 4.0 minus 2.2, that's 1.8. That's definitely a polar bond. So now the question is the molecule polar? So let's think about our rules. Rule number 1. Are there 3 or more elements in these compounds? And the answer is, for both of them, no. Rule number 2, are there lone pairs on the central atom? There's no lone pairs on any of these central atoms. Like, let me pick a different color here. Right, that does not have any lone pairs. All the electrons around it are bonded. This doesn't even have a central atom down here. It would follow rule 3, where if there is no central atom, the elements are different. So this molecule here is polar. This molecule here is nonpolar. The molecule on the top, CO2, does not satisfy any of our rules. Rule number 1, again, are there more than 3 atoms? No. Rule number 2, are there lone pairs on the central atom? No. Rule number 3, if there is no central atom and there's only 2 elements, are they different? And again, the answer is no. However, for B, rule number 3 is true, where there is no central atom and they are different elements. So that is polar. Okay, so I'd like to give you guys a minute. Why don't you guys try these? All right, and I'll be back in 2 minutes and we'll check your answers. I have some messages in the chat there. From Aisha says we have C is nonpolar, which I agree with, and D is polar. I also agree with that. I think so anyways. Actually, phosphorus might have a similar electronegativity to hydrogen, but we'll see. And Abdullah says, can we know if it's polar or not without electronegativity? No. You definitely need to look at electronegativity. So let's see. Let's try these molecules here. I'll pick blue. All right, so CH4. CH4 would look like this. And I can draw it very quickly because I've drawn CH4 about 1,000 times in my life. So there's CH4. Now, the first thing we need to ask ourselves is, are the bonds polar? So we go to our data booklet. which I have here. And we look up C and H. I'm just going to erase some of my colors here. So C is 2.6 and H is 2.2. Okay, so we'll go back to this slide. C is 2, oops, let me pick another color. So our difference in electronegativities is 2.6,
Mister,
2 or 0.4. Yes?
we can't see the screen.
Oh, sorry, I'll share it. There we go. So C, carbon is 2.6, hydrogen is 2.2. So their differences in electronegativity is 0.4. Now, hold on 1 minute. I'll write that again. 0. Now let's go back and look at a previous slide we had a week ago or a day ago. I'm going to go way, way back to this slide here. Here, if it's less than 0.4, we would say that it is a non-polar bond. But if it's 0.4 to 2, it is polar. So going back to this question, all these animations, this is a polar bond. But we have to ask ourselves, is the molecule polar? So we need to look at our 3 rules. Rule number 1, are there more than 2 different elements on the bond, or more than 3, sorry? The answer is no. Rule number 2, does the central atom have lone pairs? The answer to that is also no. And then rule number 3, if there is no central atom, well, that doesn't apply here. So even though the bonds are polar, this molecule together is nonpolar. So you can have polar bonds on a nonpolar molecule. That's not a problem. All right, let's look at pH 3. So let me go back to my periodic table here. So P is 2.2 and H is 2.2. So this is going to be interesting because they have the exact same electronegativities. So pH3 would look like this. All right, there's pH3. Oops, sorry guys. I'm going to write my electronegativity down. So 2.2 and also 2.2. So first question, are the bonds polar? Well, my difference of electronegativity is 0. Let me write that again. So the bonds are now nonpolar. So that means the molecule is nonpolar. Now, if this was something like NH3 or any other chemical really, it probably would be polar because this does satisfy rule number 2. There are lone pairs on the central atom. But if the bonds are not polar, the molecule cannot be polar. So because our bonds are nonpolar, the molecule is nonpolar. Pretty cool. Well, kind of cool. So what's next? All right. Well, honestly, guys, that's a good place to stop for today. Because the next topic is kind of a one we can do in the next class on Monday, I guess. So that's it for me today, or that's it for class today. Just remember that there is no lab next week. All right. And that's it for me. So if you have any questions, let me know. If not, have a great weekend.